basic variables are x, y, z, and whose literals or complements are x bar, y bar, z, and the expression will look like 0, 0, 0, 0, 0, 1, 0, 1, 0, and so on, and so on, right? So from this expression, you are going to get one kind of function, that is x plus xy bar plus xy bar z plus x bar. This is one kind of expression. So I can call this as a function. From starting out, I am trying to say that this is a one kind of function. And if you take one more function, x plus some yz bar, this is one kind of function, right? Next, yz bar plus z, this is one kind of function, meaning that for three inputs, for three boolean variables, I may get different kind of functions. All these functions I can call it as switching functions again, right? So means, in simple terminology, if I would like to say, right, observe, if I am going to take a function called f of x, y, z, I am generally writing xy plus z. This is one kind of a function. Right? What is the meaning of this function actually? If you take out the variables x, y, z, I will try to write clearly here: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. See guys, what does the function means? If you are going to give the inputs, any kind of inputs, the result you are going to get as 1. You are going to get as 1, right? F of x, y, z, right? When try to observe, try to take out something like, for example, I am trying to get the output for this one, xy plus z. What is xy? Somewhere xy is 1, z is 1, or somewhere z is 1. Don't worry about how I am writing this one. This also, right? So this is the corresponding outcome for this expression. Try to observe, try to substitute in this equation. You are going to get output, right? xy, 0 into 0 is 0, plus z, 1 is 1. So like this you are going to get expression. The same so this is one kind of representation of the function. The same expression, see, observe, I can write it as f of uh, what is this one? 0, 0, 1, right? So 0 comma 0 comma 1, or f of 0 comma 1 comma 1, or f of 1 comma 0 comma 1, or f of 1 comma 1 comma 0, or f of 1 comma 1 comma 1, meaning that I am trying to write all the 1 cases, right? So what does make us one? When you are going to execute this function for this function, you are going to get the output 1, or for this function output is 1, or for this function output is 1, or for this function output is 1, or for this output is function. That is the meaning of this one. When you are simply writing a function, that output is always 1, right? In another form, the same expression you can write like this, right? 0, 0, 1 means what? I can write it as x bar, y bar, z, plus 0, 1, 1 means x bar, y, z, x, y bar, z, x, y, z bar, x, y, z. This is the final equation that you are going to get when you are going to solve this equation. Or see, now try to observe, these two are equivalent. These two are equivalent. So if you are going to solve the complete expression, you will get again xy plus z only. That is the meaning of this one. Meaning that I can able to represent a function like this, or if you want I can represent the function like this, or if you want I can represent the function like this. Or there is one more another representation, that is pure representation. We can call it as canonical representation of the function. Canonical representation of the function, right? In canonical form, we are going to represent we are going to represent an expression or a function either in sum of the products form, or we can represent in the form of products of sums. So the name itself is clear. Sum of products, meaning that whatever the result, that you are trying to get, all those results you are going to produce as sum. See, if you take out simple example, a bar b bar c plus a bar b c bar. What is the meaning of this one? These are the products. All these products I am going to make. That is the meaning of sum of products or products of sums. A bar plus b bar plus c into a bar plus b plus c bar. That is the meaning of product of sums. See, whatever the equation that we got is what now? It is sum of products, meaning that a function I can able to represent in one of the canonical form is sum of the products, or I can represent in the form of product of sums. In sum of products, every term I can be call it as min term. These are the technical terminology you have to remember. Every term I can call it as min term. In product of sums, every term I can call it as max term. And this min term, how we are going to get? See, observe. This min term result is 1, meaning that in sum of products, min term represents 1. In max term, the it represents the value 0. Okay, fine. So for example, if you take the simple example, a b c, right? As I have taken here a b c, I am trying to take 3 variables, right? 0 0 0 0 0 1 0 1 0 0 1 1 1 0 1 0 1 1 0 1 1 0, right? Guys, here don't worry about why I have taken these values. I have a function f. That function resulting yields as like this. For example, this is 0 1 1 0 1 0 1 0. Assume that this is my result. For this function. Then in sum of products, how will write the expression? All the ones I will be make it as sum. See, min term is 1, right? So meaning that wherever you observe 1, I can call it as a min term. How this min term you got? Because of 0 0 1. What is 0 0 1? A bar b bar c, that is 1. Or this one, how you got? A bar b c bar, or a b bar c bar, or a bar b bar c. So it should be a b c bar, right? So this one, this is a b c bar, this is a b bar c bar. So this is one kind of representation of sum of products. What is another way of representation? I can represent in another way, that is product of sums. In product of sums, 0 will be represented as a max term. 0. See how these are going to be useful me, that we will see in the further class. Okay, where you have to consider 0 only. Right? So here try to think. In sum of products, we are going to represent like sum of the products. Here we are trying to represent the product of sums, right? So meaning that everything you are going to be represented as products first, right? So this product A, B, C. See, you have to observe the clear difference. That's why I have taken a single example I am trying to explain here, right? Here in product of sums, A represents 0, A bar represents 1. Here in sum of products, A represents 1, A bar represents 0. So that is the meaning of this min term and max term. Okay, so A, B, C. So ABC what? Again A plus B plus C. A plus B plus C. What about this 0? A plus B bar plus C bar into, what about this 0? A bar plus B plus C bar. What about this 0? I think A bar plus B bar plus C bar plus C bar. Okay, fine. This is the corresponding expression, equivalent expression for this function f. So okay, don't worry about this expression what they have given. So because of that expression, I got the result like this. So sum of product expression like this, and product of sums expression will be like this, right? So technically, we may represent sum of the products as summation of the sum of these values. What is this? A bar, B bar, C? I think it is 1, comma. This value is what? 0, 1, 0. It is 2. So you can represent this expression, sum of the product expression. Summation of, what is this value? 1, I think 2. This is what? 4. This is 4 plus 2 is 6. 1, 2, 4, 6, right? 0, 1, 2, 4, 6. And product of sums I can able to represent as max term of opposite sign. Opposite sign, right? So basically here A bar represents what? 1, right? 1, 1, 0. What is 1, 1, 0? 6. What is 1, 0, 1? 1, 0, 1 is 5. 6, 5. Right? That is the meaning of this one. Right? So the same thing if you represent it here. Pi of, what is the value of A plus B plus C? A value is 0, right? Meaning that 0, 0, 0. 0 is 0. What is this one? 0, 1, 1. 0, 1, 1 is 3. And this is what? 1, 1. A bar is 1. 1, 0, 1. 1, 0, 1 is 5. And if you observe this A bar plus B bar C bar, I think all are 1s. All are 1 means 7. 1 means 7, right? This is the corresponding product of some representation in the numerical representation. Okay, guys, if you observe some similarity here, once we get sum of the products of a function, can you able to get the products of sum or not? Simply its complement form. Okay, fine. See, so you have to know the meaning of complement, right? Complement means, for example, if you take any expression of the function a comma b comma c comma and so on, some z variables are there with values 0 and 1, and it's having expression dot operator and all these things are existed, right? So the complement of this function is you have to make the complement of all the variables, a complement, b complement, c complement and so on, z complement, and you are going to make complement of both the constants also, 1 comma 0, and their signs are also going to be changed. And I have observed one more word I have used, f duality, function duality, where you are not going to change any variables, but you are going to change the constants 1, 0 and these operators. That is the meaning of difference between f duality and f complement. See, observe. See, for example, if you are going to take x bar dot y bar, what is the complement of this one, right? X bar dot y bar whole complement, you are going to get, I think, xy whole complement, x plus y, x bar whole bar, y bar whole bar, so you are going to get x plus y. Observe. So x bar dot y bar complement is x plus y. Complement is x plus y, right? Complement means what I said, every variable complement is changed to non-complement, complement is changed to complement, and dot is changed to plus. So that's why dot is changed to plus. So that's why you are going to get x plus 1. X plus 5. Duality means what? So this is what I can call it as complement. Duality. Duality means what? You should not change the literals. You should not change the literals. Literals should be as it is, but whose operators are going to be changed. This is what I can call it as duality. I can call it as duality, right? So now try to think this x bar dot y bar is the duality of x bar plus y bar. Okay, fine. See, if you would like to extend further example, try to take out three variables a, b, c, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 0, 0, 1. Right, take out one function f. Okay, fine. I am assuming it as 0, 0, 1, 1, 0, 1, 1, 1. Let me take one more function f2, 1, 0, 1, 0, 1, 0, 1, 0. Take out function f3, for example, 1, 1, 0, 0, 0, 0, 1. Okay guys, so I have just taken some random numbers here, right? Can you able to find out for function f1, what is the sum of the products? What is sum of the products, right? Wherever I am going to observe 1, I can call it as sum of the product, right? So I think 0, 1, 2, 3. So you will get 2, 3, 5, 6, 7 is the sum of the products. What about the products of sum? Do we need to calculate? Just complement of that, right? Opposite to that, right? So from 0 to 7 you have, right? Whatever thing that you are not having, all those you can include. 0, 1, 4. So this is for function f1. What about for function f2? Summation of 0 included, 2 included, 4 included, 6 included. What about the opposite one? Product of sum. You will get as, so 1 is included, 3 is included, 5 is not there, 7 is not there. What about function f3? Summation of 0, 1, I think 6, 7. This is easy, right? We can able to write it. Product of sums is I of 2, 3, 4, 5. Right? You can get it. This is the way you can able to do. Okay. For example, my question is when you are going to get an expression. When you are going to get an expression like sum of products expression, you need to convert into product of sums. Can you able to perform this one? Yes. If it is available in this form, you can able to easily convert it into product of sums. But the thing is, you have to clearly understand the meaning of product of sums. So up to now, we thought like it's a simple one. We did very easily. But if you observe here, sum of products, right? I can call it as SOP. Right? So in SOP, you are going to have min terms. All those min terms you are going to represent in the form of 1. So what does the min term means? Min term should have all n variables what you are going to use in our expression, either it in complement form or it in uncomplemented form. See guys, if you observe this example, I am saying that this is sum of products. If you observe a min term, this min term contains all the variables what I used, a, b, c, either in min term, either in complemented form or in non-complemented form. If I say that a max term is expression is a kind of product of sum, this max term contains all the variables either in complemented form or its uncomplemented form. That is the first and basic criteria you have to be solved. You have to do. Okay. Right. So that is what required. Right. First, so when you are trying to say that they are saying that it is sum of products, it look like for example, simple. If you take an expression xy plus x bar y bar z, guys, is it actually sum of products or not? Yes, it is sum of products, but it is not in the form of min terms. Try to observe, because if you observe this particular min term, it is not containing all the n variables. What are the n variables we are trying to use? X, Y, Z, but it is not containing Z. So that's the reason it is sum of products only, but it is violating the standards of the sum of the products. Standards of the sum of the product. So whenever they have given certain kind of expression, you have to convert it into standard sum of product. You have to convert into standard sum of product. How we are going to convert into standard sum of product? Can we convert this expression? Can we do like z plus z bar plus x bar y bar z? Is there any problem for you? I can consider it as a 1. I can make it as z plus z bar. Is there any problem? No. X y z, x y z bar, x bar y bar z. That's it. This is what I can call it as a standard sum of the products. Standard sum of the product, right? This is one kind of criteria. And if you observe one more criteria, see, I am trying to make the more points after explanation only. If you observe, whatever the expression that you are trying to get, that expression is unique expression, right? In canonical representation, every expression is unique, so that opposite is some other kind of expression. Product of sums are some of the products. So every expression, every canonical expression is a unique expression. Okay, fine. So for example, if somebody asks you to give an expression, something like this. So there is an expression f of a comma b comma c. The expression is like ab plus ac bar plus bc. Is it in standard sum of the products? Obviously it is sum of the products only, but is it in the standard sum of the products? No. So you have to convert into standard sum of the product. Then what you can do? You can simply perform AB. So you can take out the respective variable with its multiplication. C plus C bar, A variable, B plus B bar, C bar, A plus A variable, BC. BC, right? Now try to make it distributive. ABC, ABC bar, AB C bar, A bar B, sorry, A B bar C bar, ABC, A bar BC. A bar BC, right? So try to take out any kind of repeated min terms. Try to take out any kind of repeated min term, right? ABC bar is common, so you can take out, right? ABC bar plus ABC bar is ABC bar only. That's the thing here. ABC plus ABC is ABC only. ABC only. ABC bar plus ABC bar is ABC bar only. Next, A bar BC. Now, is it standard sum of the products or not? I can call it as SOP. This is sum of the products. Sum of the product, right? So, guys, in kind of numerical representation, how you can represent summation of ABC represents what? You can just go ahead. One minute. So here I missed one terminology. ABC bar okay, A bar BC okay. You have to write one more terminology, A B bar C bar. B bar, right? What is this ABC defines? ABC defines 7. So I can write it as summation of this is 7, I think. So you can make 3 spaces. This is 7 and ABC bar, that is 110. 110 is 5. For any expression like that, 5. A bar BC. A bar BC is 011. 011 is 3. A B bar C bar, that is 4. So 3 4. So you can write in order. 3 4 5 7, right? Okay, fine. For example, you may get the alternative. Right? If I am going to have an expression in product of sums, f of a comma b comma c in a plus b, a plus c bar, b plus c bar, right? At the time, what you can do? You can simply again perform adding of that non-existing number, non-existing variable. A plus b plus c into c bar is what? 0 only. A plus b into b bar plus c bar, a into a bar plus b into c bar, right? Try to solve this one, right? According to distributive. So you can simply make use of a x plus yz is what? X plus y into x plus z, like x plus a plus b plus c into a plus b plus c bar, a plus b plus c bar, a plus b bar plus c bar, a plus b plus c bar, a bar plus b plus c bar, right? Yes. Now what is this value? When you say that all are normal numbers, this is what? This is product of sums. In product of sums, you will have to consider it as 0, right? A means 0, a bar means what, right? So this is 0, meaning that product of pi of 0 comma 0 comma 0 0 1. 0 0 1. 0 0 1 means what? 1. This is 0 0. Okay, fine. So before that, you have to remove the non-redundant products also, non-redundant numbers. So I think these two are repeated. Is there anything? A plus b plus c bar? Yes. A plus. So I think nothing, right? 0 1 and whatever this one. This is 0 1 1. 0 1 1 is 3. 3. Okay. This is what? 1 0 1. Guys, don't worry about these two are not from the same expression, right? So if it is from the same expression, the product of sum will be again pi of 0 1 2 and 6, but those are not from the same expression. I just made an example how to convert product of sums into standard product of sums. Standard product of sums. Okay. So for example, if somebody asks you to convert the standard sum of products to standard product of sums, or sum of the products to standard product of sums also they may ask. At the time, what you can do, for example, if the question is something like f of x y z, the standard sum of the products they may generate it as 0 1 3 4 7, right? What is the standard product of sums? Pi of capital M. You can simply write the values which are not available, 2 5 6, right? So you can simply define here. This is this should be M. Min term is small m, max term is capital M. Like this you can able to define, right? So this is the thing, right? So if you want, you can write the expression. Let's try to observe. I will try to write the expression. That is here x bar, y bar, Z bar. X bar y bar z bar plus x bar y bar z plus x bar yz 1 means x y bar z plus x y z x y. Guys, is there an unique thing? Is it an expression unique or not? Yes. And if you observe it in in product of sums, so this will be like 0 1 0, right? 0 means what? X plus y bar plus z, and 5 means what? 101 101 x bar plus y plus z bar. 6 means 110 means x bar plus y bar plus z or plus z, right? This is what standard product of sums, standard sum of the product they have given. Okay, let me take a last example. uh, for example, if you take an expression f of x comma y, where they have given as uh, x into x plus y, right? Guys, they have given the expression as product of sums, right? So this is sum, this is one sum, they have given their product, right? If they are given the product of sums, can you able to convert into sum of the products? Yes, we can do that, right? If you want to do that, so what you have to do, you have to perform the operation. So like when you are trying to perform the product of sums into some other first standard sum of the products, first you have to perform addition over the respect to remaining thing, right? So that is x plus y into y complement. Is there any problem for you? No. X plus y. Now I can able to make it distributive. X plus y into x plus y complement into x plus y, right? X into x is what? X only. X plus y into x plus y complement. Now, is it standard products of sum? Yes, it is standard products of sum. When it is standard products of sum, can you able to define it in form of numerical representation? Pi of max term of, this is what? X means 0 0 0 0 means 0 0, and this is 0 and this is 1 0 1 is 1. What is its like some of the products form? Summation of min term of, so with respect to two variables you are going to get four possibilities, like that is 2 comma 3. Now can you write the some of the standard some of the products expression? Yes, right? So what you can do here as, so 2 means what? X y bar plus x y. This is the standard sum of the product expression for the given products of